Hey all, this is a quick look at how to do number 4, and I'm going to forget the other one. There's two problems on the homework that involve this function stuff where you input values, and I'm sorry I didn't get to that in class. For some reason I thought it would come up and I didn't put it in my notes to tackle it, so here's a little help to get you through these anyway. If you take a look at, this is number 4, or something like number 4 in your homework in 1.4. By the way this is set up is you're taking various values that initially, like -8, here you're going to put it into the function f. Easy to make an error here. What you want to do is you put -8 into the function, and you want to use parentheses really, really well. So -8 has to go in parentheses as you're evaluating it. Now to see what that looks like, I'll take you over to another page that I have. Let's see if I can pull this off here. Hang on, whoop, go back a little bit. If you use a calculator here and you see how I'm using -8, and I square it, -2 times -8, and then add 3, you get out 83. If you use parentheses really well and you're really careful with your calculator, no problem, it'll get the answer for you. Use Google's toolbar. If you type that in, it actually gives you an answer. If you didn't know that, you can use any calculator, even Google's toolbar, to make that happen. So let me back up, get back to where I was. So we saw this -8 going in, and then from there you evaluate and get an 83. That's what you're going to put in. That when you have a value put into a function, you're going to get out a value. So we'll throw 83 in the mix. That means right here is 83. The next one is if you put c plus 1. Now that's a little more complicated, but those of you that have had some pre-calculus or college algebra have probably seen something like this. If you put c plus 1 into that, you put c plus 1 everywhere there used to be an x. And I use parentheses to represent where the x's used to be, and then put c plus 1 in those parentheses to keep me kind of organized. The next thing is that c plus 1 squared, that's where most errors happen. That means c plus 1 times c plus 1. You can't distribute that squared into that c plus 1. It is not c squared plus 1 squared, so don't do that. It's c plus 1 times c plus 1. And if I FOIL that out, you get c squared plus 2c plus 1. The other terms I haven't touched yet. I just did the FOIL part. Once you do that, you have like terms to combine. I noted 2 markings for numbers and 1 little slash for those c's, and if you put them together, this is what you get. And that result goes into part B above here. And by the way, the answers you see over there, one of your classmates alerted me to the errors, or to how difficult these were. And thanks to them, they got us back on track here. X plus z, I know it's blurry there, but you want to put x plus z into that function f. So again, parentheses where x used to be, x plus z goes in. There's FOILing x plus z, and then distributing the -2 to that x plus z. Just be really careful about distribution. And then once you do the FOIL and distribution, you look for like terms. There are none actually in this case. I did highlight where, the underlined parts in purple there are the non-FOILed part, the things that I did not distribute. So, but I just want you to see that the end result. I'll show you the FOIL part. This FOILed chunk here is equivalent to that chunk right there. But you can't combine anything. So that whole thing would go into part C, and that would be your answer. All right, onward. So we move into, let's see, what problem is this? Oh, there's my calculator. This is what, number 6? Really hard to read, sorry about that. But if you do number 6 here, you put in 6 into the function g of x. Now these are called compound or complex compound functions, where you're putting a number inside another. If you haven't seen this in a while, what you do is you take the inside function, that g of 6, you figure out what that is, get a result for that. So you put 6 in, square it, -6, get 30. Then you take that 30 and you put it into the function f. So f of 30 is radical 30, and you don't need to simplify those, you can just put them directly in. F of 6 is the inside part of this part B. Once you find out that's radical 6, you just put radical 6 into the g function, and that would mean you square it and take away 6. Squaring a radical 6 makes it just 6. Okay, so see, when you square radical, you get just, they cancel each other, squared and radical. 6 minus 6 is 0, that's our part B. C, you put 0 into the function f, radical 0 is 0. If you put 0 into the function g, you get -6, so that goes into the space. If you put -8 and so on, -8 goes into g, the internal function, square it, subtract 6. Don't forget, squaring a negative is positive, so it's 64 minus 6. and you get 58. That goes into the function f, and radical 58 will do. You can simplify radicals. In some cases that's important, but this case I believe WebAssign will accept that, and that's fine. It's the correct number. The next is this f of g of x. That's a little more complicated. What it means is take the whole g of x function and put it into f. So here's f. Let's start with f. What I'm going to do is put g of x in it. And that means where x used to be, there's now a g of x, the whole function goes in there. And then you can just write that whole expression in part E. G of f of x means I'm going to put the whole function f of x into g of x where there used to be an x. So I use parentheses where the x used to be, and I put that function f in its place. So if you look here, here's f of x. That's what I put in for x, and squared it. So where there used to be x's, now I'm putting f of x in its place. And when you square that radical x, you get just plain old x. And x minus 6, that's the expression you put in part f. Hope that helps. Let me know if I can help you some more.